Honeybee Obscura listeners, it's a rainy, overcast, gloomy day, so I thought, what a great day to discuss the whole concept of a colony collapsing because of Varroa mite predation. I've been through that a lot, more than I want to have been through it. It's not a happy situation, and I think that we would all be better suited for having an idea of how to deal with it and what it looks like. David's here with me. He knows all about it. He's apparently quite the professional at collapsing colonies. Is that right, David?
Yeah, that's a fair way to say it. When people would ask me in grad school what I did, I'd say, well, I'm not really a beekeeper. I'm a Varroa mite keeper. And the best way to keep Varroa mites is to just keep your bees really poorly. And so I have deliberately caused a whole lot of colonies to collapse right before my very eyes so that I could study the process. And I think that makes me particularly able to help other people navigate through it, whether something's going wrong in their colony or if they want to prevent it from happening. You know, I've got a lot of experience about what happens when you go too far down that road.
Well, I want to hear about it. Let me say first who we are and who you are, and then let's talk to our listeners. I'm Jim Tew. I'm here at Honeybee Obscura, where once a week we do something talking about some aspect of honeybees.
And I'm David Peck from Better Bee. I'm the Director of Research and Education. And whenever Jim asks me to come on the podcast, I always agree because it's always a fun conversation.
I always learn more than I can ever contribute. David, I appreciate you being here.
Welcome to Honeybee Obscura, brought to you by Growing Planet Media, the producers of the Beekeeping Today podcast. Join Jim Tew, your guide through the complexities, the beauty, the fun, and the challenges of managing honeybees. Jim hosts fun and interesting guests who take a deep dive into the intricate world of honeybees. Whether you're a seasoned beekeeper or just getting started, get ready for some plain talk that'll delve into all things honeybees.
David, did you select this topic for your PhD work, or was it assigned? Was there funding for it, or why would a person decide to get in the business of exploring kind of a gloomy aspect of beekeeping?
It was all me, and I'm responsible for disappointing and depressing my PhD advisor, Tom Seeley, for a few years there, because he loves honeybees because they're cooperative and they're so sophisticated and they do such amazing, wonderful things and they make delicious honey. But, you know, I came into the lab as a parasitologist. I think it's really cool when animals cheat and exploit each other and attack each other. And so I came in right from the get-go to study Varroa mites, and the bees were just incidental. That's just where the Varroa mites lived. And then I fell in love with the honeybees as a part of that work. But right from the get-go, when I showed up, I said, Tom, I want to come in. I want to study bee parasites. And he said, that's good because they sure need studying. You know, I knew as I designed my experiments that some of the things that I would study, like how Varroa mites spread from a colony as it collapses, were going to require me to cause that colony to collapse. So I had one apiary at one summer in particular where their full-time job was just manufacturing more Varroa mites than they could handle so that then I could take colonies and move them out and set them up for experiments where they were doomed to fail.
You touch an interesting subject unintentionally. For those of us who keep bees, love bees, think about bees, work with bees, you can't do any of that if you don't get by this Varroa thing first. In essence, you got to keep Varroa first.
Right.
Before you can keep your bees.
Well, the nice thing about Varroa is that they keep themselves. If the bees are alive, the Varroa are there, so you have to manage and intervene. But you're right. The great thing about learning beekeeping while I was studying Varroa was I made all the classic beekeeper mistakes, but all it did was it increased my Varroa population, which was what I wanted in the first place. So I didn't have to be a good beekeeper to study the mites. I had to be a bad beekeeper, and that's an awful lot easier.
Well, before we go any farther, you and I talked about this before we started here just a bit ago, that we keep referring to these colonies collapsing. I'd like for you to discuss colony collapse disorder compared to colonies collapsing from excessive Varroa predation.
We use this term collapse, and it can sometimes get us in trouble because a lot of people are familiar with CCD, or colony collapse disorder, as a very specific phenomenon. It was this observation that suddenly, a couple 10 plus years ago, all the colonies were dying, all the bees were vanishing. And so they went out and we wanted to study what was causing colony collapse disorder. And so First, they described exactly what they were talking about, these very specific symptoms of a colony basically just losing the thread and suddenly most of the bee population vanishing. Then we tried to figure out what had caused it. And a great deal of research has gone to show us that a significant contributor is high levels of Varroa, although there are other things that can also lead to those symptoms. That's not quite what we're talking about today. When we're talking about a colony that collapses because of Varroa, we're really just talking about, what a statistician might call a demographic collapse. There's this problem where the number of bees that are born and grow up and mature every week are much lower than the number of bees that are dying from one cause or the other. And so what we observe when Varroa causes a colony's population to collapse is that suddenly we don't have as many adult bees. We've got a lot of brood that are typically left uncared for and untended. And there's this whole suite of symptoms that you can observe in a colony that is going through this Varroa and virus-caused population crash.
The way that affected me, as you tell the story, I do want to say it was several years ago, in my defense. The colony looked great, Dr. Peck. I mean, it was a powerful colony that was thriving. It was booming. So, if it's working, don't fix it kind of mentality is what I had. As time rocked on, you begin to notice that not quite as much flight activity as there was there for a while. And then as you wait another week or so, you begin to see more twisted wing bees out in the grass in front there, and you see some symptoms, and you begin to get that thing that you get before you have an idea. Something's not right here. And so then when you open it up, it's just chaos inside. And my first thought was that I had American foul brood. And I assumed what I was looking at was parasitic mite syndrome. So I had this big panic. And I thought, oh, my stars, now I wish I had Varroa. I've got all this infectious American foul brood to deal with, and my apiary is contaminated. And that was my first exposure to having a colony collapse. I thought that if this is a booming buster beehive, leave it alone. And by leaving it alone, they went crazy.
I am so glad that you said that, because that is maybe the most important lesson I can teach a beekeeper is that, when I said that I set up that apiary to breed those mites and to cause those colonies to die, people think, oh, it must have been so dreary. You'd go out, how could you even keep the bees alive? Well, for most of the summer, those were some of my most productive colonies. They were doing great. I was just giving them lots of space for brood. I was feeding them. They were growing and growing and growing. They were booming colonies. They were healthy colonies. They had young queens that I'd started them off with. Everything was great. The only problem was that mite population was getting higher and higher and higher and higher. So, I think that people often fall into the trap that you describe, which is that you look out at the colony and you think, I haven't had time to test my mites, but if they were really sick, surely they would look sick. So I probably don't have to do any intervention. And that is a major mistake. One of the things that we did after I took this job at Better Bee is I started describing this story to some of the folks here. And they said, gosh, wouldn't that be great to teach other people about? So what we did was we took a hive and we set it up at my own personal home apiary, because they didn't want to do it in any of the company's bee yards.
Okay.
But we set it up out there, and we did exactly what I'd done during my research. I just bred Varroa mites and didn't treat them. And that colony was doing great. They were really strong. They were really healthy. They made a nice honey crop. And we went out, we recorded them in, I think it was August. And then clear as day, you go out to the apiary, you can see this is a strong colony. This is a healthy colony. There's a lot of flight. And we took a mite wash, and it was way too high. And then we didn't do anything. We didn't intervene. And we went back there, a few weeks, a month later, and we saw that there were hardly any bees. The brood were all chilled and dying and half decomposed. And the colony had completely collapsed. It was caused by the mites, but there was no prelude of a long, slow, graceful decline. It was a booming colony, and then it was a colony that was done, not a colony that slowly sort of frittered itself away.
Well, you're describing my situation. I sound lazy, Dr. Peck. I sound lazy for not wanting to open. This is a big colony. It's 3 supers, 2 deeps. This is going to be a lot of work. And this is, it's really functioning nicely. And I just, you knew in your heart, you got Varroa. The whole world has Varroa, essentially. So if you're not treating, you're not doing something. But you just, in my case, I just wanted to believe that somehow this was a special colony that had figured out a way to work around it, and it really had not. So everything you're saying, I completely agree with. It seemed to happen abruptly. And I wonder if you know what that tilt point is, when all of a sudden It looks like it's all of a sudden. Maybe it's not all of a sudden. Maybe it was happening all along, but it reached a tipping point where this colony no longer is going to function as a hive.
It's a little bit of both. I think that there's definitely a perception that we humans have that everything's great, 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 terrible, and that they just sort of fall off a cliff. And I don't think that's quite the case. We know that honeybees are very adaptable. And if, half of the workforce of a colony dies, half of the foragers die, you're going to have some young bees that should have been poking around inside who suddenly become foragers and go out and start flying. So I think that, you'll see the same traffic at the entrance, even if you've got older bees starting to keel over and die at too fast a rate. And the colony will appear to be okay until it isn't. And that, I think that's true of a lot of things. Things are fine until they aren't. We've got a lot of examples of systems that are able to keep themselves stable as long as they've got that ability. And when they lose the ability, things just fall to pieces instantly. And I think we see that in our colonies as well, that the bees are wallpapering over some of their health issues until they just can't do it anymore. But other than that, there's been a lot of research done on this phenomenon, how it is that a colony can appear to be healthy and then suddenly be in dire straits. And I don't think that we know really confidently exactly what it is. Is it the deformed wing virus getting into the brains of these bees that make them less efficient? Is it them getting lost and sort of drifting off and not coming home? Or is it that their lifespan is reduced? They go out and they die, or they die underneath in the bottom of the hive, and they get hauled out and tossed into the grass. We're just not sure exactly how it is that when that tipping point arrives, the colony so quickly appears to decline.
You had a great quote there a bit ago. Things are fine until they're not.
Right.
that describes life, all aspects of life. Let's take a short break and hear from our sponsor. And when we come back, let's discuss exactly what you think a Varroa bomb is.
Winter's chill won't last forever. It's time to think of spring. On warm days, take a break from hibernation and check to see if your bees are out and about. Knock on wood, or better yet, a hive. No buzz? Can't hear the hum? Uh-oh. Time to think ahead. You might need to replenish your colony. Fear not. Head to betterbee.com/bees and secure your package or new colony now. Don't be left out in the cold. Plan ahead. Because at Better Bee, we're making sure your spring bees are all abuzz.
All right, so we've got this mess. This colony has completely collapsed. Varroa has taken over the colony, and we've got a real mess. What does that mean for the other bees in my apiary? What does that mean for cleaning up that equipment? What does that mean for the future of my bee operation in this yard?
Well, the consequences for the equipment left behind by a colony that has collapsed are pretty straightforward. Varroa is not going to live on your equipment for 6 months until you get your new package or your new swarm and move them in. So you don't really have to worry about the mites lingering inside the frames or the combs or the boxes. The problem is those mites aren't all just going to gracefully accept their demise. They are going to take any opportunity that they've got to get into other colonies nearby. And so we know that when a colony gets very high mite levels, and especially when they get high mite levels and then they start to die, we know that the mite populations in colonies nearby also increase. That's something that has been observed over and over, and you can observe it in your own apiary if you just stop treating and managing your mites properly. So one of the projects that I did during my doctoral work was trying to study exactly how it is that mites get from hive A to hive B. How is it that these Varroa mites are getting into the previously healthy hives nearby? And we said, look, there's no way that a Varroa mite's crawling down through the grass, past all the ants and the spiders, and then up the hive stand into the next hive over. The only way that a mite gets into a new colony is riding on a bee. And so the two circumstances where that can happen is if one of those bees from that infested hive leaves with a Varroa mite on her body, and then on her way back home decides that she's going to go visit the neighbors instead of going into her own hive. And that's a behavior that we call drift. It's a worker that either because she got confused or for whatever other reason, and I say worker, it could also be a drone, they're going to fly out, and instead of returning to the home hive, they're going to go into the neighbor's house. And if they are carrying a Varroa mite, even if that bee arrives and gets hassled by the guards and the guards sting her and then she gets dragged out to the entrance, if that mite is swift and agile enough, she can jump onto one of the guards and ride them right back inside that evening and then set to reproducing. So we know that drift is one way that they can spread. We also know that another way you can spread mites between colonies is through robbing. If one of the colonies in the apiary goes in and starts robbing the sick one, and of course, the weaker they get and the closer they get to collapse, the more easy they are to get robbed by other bees. Well, that colony is going to have a perfect opportunity for mites to jump onto the robbers and then ride them home to the big, strong, healthy colony that sent them out as the raiding party. So one of the projects that we tried to do was to study exactly those behaviors, drifting and robbing between colonies, to try to figure out, well, which of these two things is really spreading the mites. And so what we did, we published a paper, and the title of it is something like Mite Bombs or Robber Lures. And we did that because what we realized is this idea of a mite bomb, a sick colony full of mites that's just going to blast them out into the whole apiary, didn't really ring true to what we observed. We saw that as the colonies with high mites, the mite levels got higher and higher and higher, they did lead to some drifting of bees into the nearby colonies, and those colonies did have slight increases in their mite populations. But the really dramatic spikes in the mite population happened when robbing took place. We observed that robbing firsthand, and we watched as huge numbers of robbers came and went, and therefore huge numbers of mites wound up in the neighboring colonies. I will say, at the same time, the reason that we sort of suggested that idea of talking about robber lures is that might be a better description of what's really going on. It's less that a colony sort of blew up and blasted all of their bees and mites out into the apiary. It's more that this colony got sick and then the mites sort of booby-trapped it for the robbers that were going to get tempted to come inside and pick up some honey. At the same time I was doing that project, Randy Oliver in California was doing his own study of these same things. And so Randy has written a number of articles on his drift and robbing and mite spread research. And what's interesting is that Randy found basically the opposite of what we did. We said in the fall in upstate New York, where we did this study, drift was negligible, robbing was really significant. What Randy found in California, where he studied, is drift was primarily, he thought, responsible for spreading the mites, and robbing may have been happening a little bit between a couple of the apiaries. So what we concluded was this is a complex phenomenon. It's not straightforward. And so people say, oh, are you mad at Randy because he disproved your hypothesis? And I said, no, neither of us disproved anything. We just both did an experiment. We both collected data and reported it. And what we've learned is bees in different places, in different climates, under different circumstances, are going to spread mites probably in different ways.
What results then is seemingly these intelligent mites realized that their host was dead and dying, and they made this apparent conscious decision to abandon ship. But in reality, isn't it more of a mite? Here's a bee. I'm a mite. I need a ride. I'll take a ride. It's not that this colony is dying. It's just that I need a bee right here, right now. And I'm making no decision other than that decision to grab onto that bee.
Part of it is definitely that. It's a lot easier, if half the bees or 3/4 of the adult bees in the hive have recently died, this collapse that we're talking about. Obviously, a mite wandering around looking for someone to jump onto is more likely to find a robber because the robber is now boosting the adult bee population. However, there is some really interesting research that's been done, and maybe we can link it in the podcast description, but there's been some good work that has shown that as a colony's mite level gets higher and higher and higher, those mites that prefer to ride around on just the young nurse bees, they relax that preference. They can smell the difference between a young bee and an old one, and they become more interested in, or at least more willing to, ride around on an older bee, a bee like a robber coming in, or a bee like a forager that might fly out and then, if the mite is lucky, drift into another susceptible hive. So there's some sophistication going on, but we don't want to overestimate the intelligence or sophistication of these tiny little, mites with their teeny little brains. At the same time, one of the pieces of advice that I always give people is never underestimate a parasite. They're gross. We don't like them. They spread disease. They do all sorts of nasty stuff to our bees or to us. And so we don't like them. And so we sort of have a natural human bias to underestimate them, to think that they're ignorant and miserable and slimy and wretched. But, if you look at the behavior of a mite or of a tick or, of the tapeworm, what you'll find is that they are extremely good at the things that they have to be good at in order to survive. And Varroa have to be good at managing, healthy colonies and sick colonies and at spreading and getting to move into that next generation. So, what I found as a mite scientist over and over again is if I underestimate them, I wind up feeling foolish. It's hard to overestimate them because they wind up being pretty darn sophisticated if you look closely and give them a chance to show off what they're up to.
They're an admirable foe. I mean, they've taken the best the world has to offer against them, and they're bloodied, but they're still standing.
Absolutely.
Give us some closing points on what you see happening now. So clean the apiary up, get a fresh package, wait a few weeks, the mites die off, and start over again next season.
If you have a colony that collapses due to high mites, you have to assume that some of those mites made it out and that they've spread. And they might spread into your apiary, they might spread into your neighbor's apiary, they might spread into the feral colony living, you lost a swarm 2 years ago and they moved into the tree and they're still up there. So any bees in your landscape can harbor Varroa. And so if you've had an event where there were a whole lot of mites and some of them might have spread, you need to be more sensitive to Varroa in your landscape, in your neighborhood. If you've been keeping all of your mite populations really low for the last couple of years and you don't have any beekeeping neighbors or you're working with your neighbors and they're keeping their mites low too, well, it's entirely possible that your mite pressure, that invasion pressure into your apiary is going to be a little lower. And you might be able to, eliminate one of the treatments you're doing each year as long as you stay on top of the other 2 or 3 or 4 or whatever you're doing. So I think it's just a matter of keeping yourself aware of how many mites you've got in each of your hives and remembering that their job is to reproduce and multiply and spread. And so they're going to keep doing that. So you better make sure that you're staying on top of it.
Don't you have a video that you've made?
Yeah, as I mentioned, we did that experiment here at Better Bee, that project where we showed off how quickly a colony can go from booming and healthy to really, really limping along and then dead. And so I'll make sure that we link to that too. It's a video called The Collapse of a High Mite Hive. And we did that just to show people what it looks like. And what I've found, it saves me an awful lot of time every year because people call us up and they say, I don't know what happened. My bees suddenly died. I just can't explain it. They were doing great. And I say, why don't you watch this 5-minute video, and at the end of it, I'm happy to talk to you if you don't think that Varroa caused your problem. But most of the people who watch it go, you know what? That's exactly what I saw.
Yeah.
I must have been the mites. And then I know that I'm talking to them about Varroa and not something scarier like American foul brood or pesticide kill or something like that. Varroa are a pernicious foe, but they're manageable. We've got tools to fight them. It's a lot easier to keep your Varroa mites low in your hive than it is to convince the farmer next door to stop spraying a pesticide that might be hurting your bees. So, of all of the challenges we've got before us, it's the one that's in some ways the most manageable. It just requires an awful lot of management from us.
Well, Dr. David Peck, it's always a pleasure to talk with you. I'm always a better person for listening and discussing these things with you. I wish we could end on a bright note, but if you don't treat and control Varroa, they're going to treat and control your bees.
The only bright note I can offer is if you do treat and you do control Varroa, then you can get back to the fun of beekeeping and you don't have to spend quite as much time worrying about the downsides of a parasite infestation.
All right. Thank you for talking to me, sir. I look forward to chatting with you again soon.
Thank you for having me. It's always a pleasure.